Hello, everyone, and yeah, today we're going to be going through the Gymnasium overview and kind of the basic process of how it works. Um, cool. So I guess to start off with, just like at a very high level overview, we can think of Gymnasium as operating on two different types of on two different types of files. So you have build files, which are things that declare top level dependencies only. Um, So you can think of this as like maybe like a pip file, sorry, like a pip requirements file, where you only know the top level requirements. Um, and in order for you to get the entire set of requirements, you have to do an extra step. Then you have a separate set of files that do this, and these are lock files. So these are static files that already declare the state of the dependencies to be installed, or how they're installed at the time. So this is how Gymnasium gets your dependencies. From there, you have a second step, which is going to be for software composition analysis. After that, you're going to have actual scanning of vulnerabilities for these dependencies. And at the moment, the way this works is we have a secondary repository called Gymnasium DB. Sorry, previously called Gymnasium DB. It's now called the GitLab advisory database. And this GitLab advisory database um, contains entries in YAML for a couple of different packages. So you can have different things like Conan, Go, Maven, a variety of different package types. Um, so these will be have house entries that say package A versions 1 through 2, for example, are vulnerable to this specific advisory. And Gymnasium will consume that and try to match up the dependencies that are found in your project and see this. But apart from this, it doesn't really have much more logic on top of that it applies, which is why there's room for improvement as far as like what is actually reachable in your code and not just included in some file that happens to be output. Yeah, so I guess I'll open up the room as far as like or the floor as far as like is there anything like in particular you'd like to see, like more of like the report generation side of things, or did you want to dive a little further into the parsers themselves, for example?
Actually, I wanted to know how you run. How can you tell Gymnasium on what file or what repository you want to scan? So I know there is a flag like called the target directory or target dir,
Yeah.
but if you run it without this flag, so what's gonna happen? What is the default behavior?
So the default behavior is to run on the current directory.
Hmm.
Um, so if you just let it run, it will just run on whatever the directory you're currently on. Um, yeah, I guess it depends as well. Like so depending on the analyzer, you might not be able to just run it through the binary. Like I said, there's two different forms of files. There's one where you can just start parsing the file automatically, and there's a different set of files called the we can just refer to them as build files, where you have to do an extra step, which is first you have to build the project. And then because of this, where there is like some coupling between the binary and the runtime dependencies that are installed on the machine. Which is why we normally recommend running this. Like if you're running this, to run it within the Docker images that are provided. So for example, you can do and then do this for them. Yeah. So the biggest ones are going to be Gymnasium. Like if you're doing anything with Python or with Gymnasium, with Maven, those will not work because it's expecting a specific setup of what's locally installed. But um yeah, the biggest thing is just to like set it to the working directory. The way I usually run it is just running it with local directory. So I can provide an example here once this one finishes downloading. Um yeah, I guess and like Um, so yeah, so go back here. Um, so we have yeah, we have a couple of projects here, so I'll just do this. The um oh, that's right. We have to do okay, so a little bit of I guess like for like the actual gymnasium project, we include some test projects that you can use to see how this will run. These are all housed underneath the QA fixtures directory. So if you look, you'll have a couple of them like Go modules or Java or GS. Like for they're separated by in the same format, which is like you'll first have the language, and then afterwards you'll have the package manager that was used.
Yeah.
So for JavaScript, you can if you wanted to use JavaScript, it would just be JS-npm. So we can take that as an example here. And then you have to use this very long Docker command, which we can probably make into a script here. But you can just have to mount the volume directly of the directory where your project is. So in this case, it would be like the current directory, which is QA, appended with QA expect, oh sorry, fixtures, and then JS npm. And I'm gonna map that to a local volume that I just call workspace, and then set my working directory with a -w to workspace. Um, and this all gets passed on to, and then this we're gonna be running this through the analyzer. Um, so you have more control over it. You can just say, I think this one runs on the Gymnasium base image itself runs on Alpine, so you have to say ash since there's no bash installed locally. But now it's going to drop me up into a shell here that has the local project locally mounted, and you have a couple of variants of it. So with npm, there's been quite a few. There's been different improvements throughout time. So you have like version one, which was the original version of the schema used for the log file that was supported. And then later on came version two. So you have it separated here, and there's a couple of other edge cases that we have created test projects for. So I can say I want to run against log file version two. Um, and there's a yeah, so then you can just start running the analyzer from here. But there's a couple of other options that I find helpful. So if you wanna Yeah, if you want to have like verbose logging, the biggest one is to set the secure log level to debug, and then you can say analyzer run. And it'll show you exactly where it's running locally. So right now it's going to be um yeah, it'll start telling you where it's like finding things. So let me just go up so you can see a little bit better. And then okay, so you'll have things like the finder here that'll pop up. So it's going to tell you it's exactly where it's inspecting. And the default is always in the regular directory. But if you wanted to have a little bit more precision over it, you would just say, I want to run on the target directory, um, which is going to be, say I want to run it on the default project that was in the parent directory above. Um, and so you can do that as well. And then the reports are dropped into that same directory where you ran the analyzer from. So you'll have things like like for example right here you'll have like the dependency report. You'll have the SBOM itself here. You also have an SBOM manifest. But the two biggest ones that we ingest today are going to be the dependency scanning report and the SBOM report. The dependency
Yeah.
scanning report contains all the vulnerabilities, and the SBOM just contains the just the dependencies themselves.
Yeah.
Sorry.
Yeah, it's nice. And okay, so you're using the first one contains the CVEs, right?
Yes, that one will
Yeah.
contain all the advisories only.
Yeah. All right. And I have a general question more about how the Gymnasium CI is working because I know that is taking the template from job/dependency scanning.yaml and
Mhm.
then there is like a bunch of rules for each of the optional stages that this is how it checks how it's supposed to be run. Because my question is if I'm using if I have a Python repository for example, how can how Gymnasium knows which kind of language I'm using? So this is what I'm trying to understand.
Okay. Yeah, definitely. So like if we go back to the repository here, um, this logic is all housed underneath the I think it's called the Finder. So this is going to be inside the Finder repository. So it's that there's two steps here. As far as like the identification. So you have the first rules, which are the ones that um, we have three analyzers. We have Gymnasium, Gymnasium Python, and Gymnasium Maven. Gymnasium Python is only for Python projects, and then Maven for anything Java related. So things like Gradle are also included. Um, so if we were to reduce running these analyzers and creating separate jobs every single time, there's some rules that are filtering there on the extensions of the files. But then after that happens, like once you want to filter it down even further, let's say from the Python types, then it gets this gets delegated to the analyzer here, and that's all in the Finder. So if you go to the Finder um, itself, you'll have a couple of see, you'll have a couple of different mappings here. So you'll have like the package managers here. And that's what will tell you like this is where you'll have the different files that are mapped to each other. So at different times the you may have like if you have any competing, so like let's say you have two different package managers that are competing, it's whoever was registered first that wins.
Oh,
So that's the approach that we've taken. Um, Side of that, I don't think, yeah. I think you can also like verify this by just like if you like use a debug logging level, it will tell you like this is conflicting. And it'll tell you exactly why it was chosen. So it'll tell you all the list of competing package managers and tell you which one was the one that was chosen finally. Which is good, like it says, gonna tell you it was the first one. That's the tiebreaker that we use in those cases. Um, yeah, so see, so this is the files that are supported for like anything that are like that's anything that's related. You do have a second one, which is like the parser. So if you were to look at the cargo one, which is like the newest one, it would also tell you which one was so this is where it's registered right here. So it'll tell you which is the parser that we're using. So for like cargo lock, we have a specific parser here. There's a little bit of magic involved in this, and I'm not super keen on it right now, which is something we're looking to change, but it uses init functions. So unless you declare this inside of like for example this main file here, unless you declare this just to import it in some manner, it will just not ever register. So it's magical and it is definitely like I think looking back is somewhere where we could improve upon so we can make it more explicit and people know why something may not be picked up in the future instead of knowing this magical comment that you have to have. Um, yeah. Does that like make any sense or is like something I can
Yeah,
dive into?
yeah, it sounds great. I think I have like one more question that can really help me. If I want to run the entire Gymnasium CI in locally, I don't want to create a merge request and see the CIs work over there. I want to do it locally before. How can I do that? Is it possible?
Yeah. So you just want the reports themselves. You don't want to, you don't
Uh,
care about anything else.
no, I do care about I want to if I'm gonna do some changes, let's say I'm gonna do some changes in the how the CIs work. I want to add a new step after the Gymnasium Python is working, let's say. And I want to add a new stage I want it to do anything else, but I want to test it locally before, I'm taking it remotely to the gitlabs.com CI.
Okay.
How can I get that?
Yeah. So this one, let me see. I don't think this is something that we document, so I think that's something good to add here. Uh, yeah, I don't think we have this in the README either. So there is a couple of things you can do. Sorry, let me just I forgot the GLab way to do this, but every time you add something like if you're making changes to the analyzer themselves, like if like it's in within the analyzer code, then every time you open up when you open up an MR and you push a change, it'll create a temporary image that you can run. So it'll you just have to note the name of the full name and tag of that image. And then locally inside of your like the template that you're including, you can do something like let's see custom something like this. So let's say you include I think it's jobs
Yeah.
and let's see scanning. I'm not gonna be super yeah, I'm not gonna be super picky about the syntax, but then right here you can have like the gymnasium. Um like if you were to have like the gymnasium job, you can just override that with your local image here. And then that's what I would do. It's just the image that you're testing with. If you wanted to modify the template itself, then
Yes.
you would just have to modify the what this is pointing to for so inside of the let's see, I think it's here in the you just have to modify that inside of your GDK. So I think it should be here. Yeah, so you would modify it here instead, since that's where it would pull it from that local instance of templates.
So okay, I want to see that I got it. So if I want to change the template, I want to add a new step. Like every time you finish Gymnasium Python dependency scanning, I want you to try to that, you try to run another thing, let's say the advanced task of us, just to get the
Mhm.
reachability thing. Then I want to add it as a step after
Yeah.
the Gymnasium Python dependency. So I will have to add it here where you show me right now and put it inside my GDK, right? This is the
Yeah.
only way to test it.
Yes. Well, it's already in your GDK. This is housed inside the GitLab repository itself. So
Mhm.
yeah, it's just under the CI templates portion of the library. So you just have to modify it here and then run the job after modifying it since it'll pull from there. Same thing as normal. You just put include and that like the same thing. But this is to my knowledge that the only way it can work because of offline requirements. So if you were to have like a completely offline instance, then that's why it defaults to whatever is locally on your GitLab.
All right. Yeah, okay, this is the way of doing it. That's nice. And yeah. So no, you answer everything I asked. I wanted to know if I can run a specific branch of my Gymnasium, and you said just use the custom temp image that's created whenever you are m- pushing the code into a merge request, right? Right? Yeah,
Yeah.
whatever exactly what you're showing
So
here.
yeah, so you would just so let's see. Every single time there's like merge request created here, you'll have a couple like um yeah, so like if you like for example, there's one right here to update Golang, a Golang dependency. There's gonna be an image created for that. So let me just open that up. I think this one is um actually sorry, let me look at that again. It's gonna be 785. And then I think this is gonna where's the actually I don't think we have this in GLab, but yeah, there's gonna be a job that gets listed here. So if I were to run the just on the latest one, um yeah, so if you go here, you'll have like a couple of them. So let's take this gymnasium one as an example. You'll see that it'll be a build a temp image here. So in this build temp image job, that's the one that will have the tag that gets generated for it. It's based off of your commits, if I remember correctly. So it should be pretty deterministic in that manner, but you just take this and you plug it in and it'll go fetch it from Git. You can just get it so it fetches it from the official Gymnasium container registry. So that's if you want to do anything in that test anything that's specifically inside of the analyze like a custom analyzer change.
All right. Yeah, that sounds good.
Um, yeah, and I guess like to reduce the feedback cycle, like if you want to test something quickly, the best way to do that is to do that through the Docker command. I think this one is documented here. And I don't think it is actually, but yeah, I can link this one afterwards inside of the. It's the one that is the Docker run. Yeah, this one here. This one's like if you want to run something that's like specifically for Gymnasium Python or Gymnasium Maven, I think is what you're most likely find this useful, just because it expects, like I said, like a a very specific structure of like where the analyzer is. And for like Gymnasium Maven, there's definitely been a lot of customization. So I would recommend definitely just running it with this command instead of trying to build the analyzer locally.
Yeah, I mean, that makes sense. That makes sense. Yeah.
Yeah. Yeah. Outside of that, if you have any like questions as far as like or any suggestions, as well as like something like you're finding that can be improved, definitely let us know. Um, I'm currently working on improving like this the analyzer so that we can make it a little bit more straightforward to contribute to. So that's another thing that we're focusing on. And over time, we've made a lot of trade-offs to get things shipped and working, but something that's usable. But now we're trying to go back and improve on that as well so that we can have the best of both things.
Yeah. Okay, I think I can help with that because I'm doing it for the first time. And as a first timer, I can find, okay, we're missing something here in the README, we're missing something there that would make everything easier. So I definitely will keep in touch with you.
Yeah, thank you so much. I really
Yeah,
appreciate
yeah.
that.
Thank you very much.
Awesome. Well, yeah, if you have a yeah, if you have any questions, just feel free to ping me in an issue or just DM me, whatever works best for you. I'll do my best to answer the question. If not, if it's not something that's documented either, yeah, I'll like you can let me know and I'll add that as well.
All right. Yeah, no problem. Yeah.
Awesome.
Thank you very much for your time.
Yeah, you're welcome. Thanks, Joey. Have a nice day.
Bye.